Now that we tested our launch job and we know that it will pick up two models, or actually a set of two predictions from the baseline and the candidate model, and compare and evaluate them, we can set up an automation that will do the same thing in an automated way whenever a new model is added to model registry, or whenever a specific alias like candidate is added to a model version. So let's switch to model registry that we already know very well, and try to do this thing in model registry. Okay, so we can see our small instruct LLM. We can see the versions. Actually, let me remove this candidate tag for now. We will add it later on to trigger the automation. So if we go back to this model, we can see there are no automations added here yet. So let's add a new automation. And we can do run this automation either whenever a new version is added to a registered model, or whenever an alias is added to a model version. So in this case, let's do it based on an alias. And again, we will be using the candidate alias, and the action is going to be a job, a weights and biases job. And in the next step, we'll select the job, and this is going to be our eval job that we just recently run, and we can change some of the settings here and do some overrides. Maybe instead of running all of the samples, let's just make sure we run this on 100 samples, and we use the same OpenAI model. We'll take the baseline alias from model registry as our baseline, and the alias eval is candidate. But since this is an automation that is triggered based on an alias, maybe at some stage in the future we may want to change that alias. So instead of hard coding this candidate here, I can copy this dynamic setting, which is referring to the alias being updated that triggers the automation. And instead of hard coding candidate, I may want to put this alias variable here in this override settings. My destination project is going to be Tiny Llama, which is the same, and my queue is going to be my evaluate Docker queue. And the automation name, let's just call this evaluate. And we will be using GPT-4 as a judge to compare candidate versus baseline. And let's create this automation. So this automation is created, and let's now add our candidate tag back to this model. And let's see what's happening. Let's go back to this model, and we can take a look at the queue. And we can see there is a new job that has been queued. If we check our agent here that is running on my computer, it seems like this job has been started. It picked up the data and is running the evaluation now. And we can see now the candidate preference score is minus 0.07, which means the candidate is slightly worse than the baseline. And again, this is a different, since we're comparing the same models, but the score is a bit different because we just took 100 samples now. So probably like this first 100 samples, the baseline look better, but it's still in the same range. It seems like the candidate and the baseline are very similar. So let's take a look at these results, and we can see now this job is finished. We can take a look at it in weights and biases. And other than this candidate preference score, we're also logging a table with comparisons between looking at the prompt. We're looking at the baseline response, the candidate response. We have the choice which is 0 for a tie, -1 for baseline, and 1 for our candidate model. And we can also see the reason why the LLM picked a specific answer. So I want to take a look at one when there is not a tie, but in this case, the baseline is preferred. So take a look at the instruction, generate a list of 5 potential threats to digital security. You can see the response from the baseline model, and cross-site scripting, cross-site request forgery, that is repeated 3 times. And let's take a look at the response from the candidate model, and it's cross-site scripting along with the description. And let's look at the reasoning from the LLM. Both models have issues. Model A repeats the same threat and description multiple times, which doesn't fulfill the instruction to list 5 different threats. Model B repeats the same description for one threat multiple times, which is redundant and doesn't provide additional threats. However, Model A at least provides 2 different threats, even if they are repeated, while Model B provides only 1, which is a pretty solid reasoning. So I would agree in this case. And this way we can do some interpretation. We can actually see that both of these generations are pretty bad. So let's take a look again at, we can take a look again at the model that we have here as the candidate. So let's go back to the overview, and remember we have this lineage, and we're also like saving in our config the baseline and the evaluation model path. So we can see this is the small instruct LLM v3, and if we take a look at the v3 here and view this, we can go back to the run that created this model. We can check the config and the settings, and let's take a look. Let's take a look at some of the settings. If anything comes up as being causing like this this poor results. And that reminds me that again we run this model in a debug mode with max steps equal 20, which is not not giving the model enough chances to really learn following instructions. So in the next step, let's go back to training the model, and this time we will train this model for a bit longer and run this evaluation again and see the result, and hopefully now the outcome will be much better.